Well, hi all. Welcome to GradStats 2024 Lab Series. In Lab 5 in RStudio, we're working with Chi-Square tests. And the Chi-Square is a non-parametric test used when our data are categorical in nature. And we're looking to see if the frequencies in those categorical variables are similar or are they significantly different than what we would have expected. Now, the two types of Chi-Square tests we're going to be working with are the test for independence and the goodness of fit test. Materials you're going to need for this lab are a data set called survey_24_lab5.dat, so a tab delimited file. You'll need your Lab5 script to work with, and I also have a doc called Prep Factors for RStudio that helps us a little bit with the importing process that I wanted to show you. So grab those items, open up RStudio, and we'll get started. Opening in RStudio, we have our Lab5 script, and again our Chi-Square, which is a non-parametric test. Our goals are to conduct two Chi-Square test for independence, and then a Chi-Square goodness of fit test. And then pulling the information from our output and getting it to a write-up format, right? So the packages we'll use are Tidyverse, Janitor, Psych, and VCD. And we'll start by loading up Tidyverse and getting ready to import the data set. And this data set is tab delimited, and I wanted to show you a different way that we can import data in these different formats. And it's by using a kind of an import wizard that RStudio has built in. So we're going to go towards this, but I wanted to let you know a couple of tips. When we're setting factors during the import, we have to pay attention to the exact spelling, including case-sensitive stuff, right? And what I tend to do when I know I'm going to import this way is I set up either a Word doc or text file with the labels that are easy for me to copy paste instead of trying to type them in like slowly. And you'll see what I mean. So what I want you to have open is the Word doc that says Prep Factors for RStudio, and it's got all of our labels kind of pre-typed for the import. And these have to be exactly the same as they are in the data set. So any kind of differences means that RStudio won't know what level that is. And you'll see what I mean in a moment. But I have my little cheat sheet here for helping import. So I've already loaded Tidyverse, and I already have the data set in my working folder. So I'm ready to do this import from text. So I'll go over to the environment to import data set and go from text reader. And this is my import dialog box. I'm going to browse to my file, which is Survey 2024 Lab5 DAT. And as we open up this, you see that it's all scrunched together because it's thinking that the data are comma delimited, and that's not the case. So first I'm going to make it tab delimited so it can sort itself out. And that's much better. I'm also going to reduce the name of this so I don't have to type so much in my code and just call it Lab5. Now I can go through. I'm going to set ID to character right here, in the data preview box. And it does take a little second to update the information when I set it. Now for sex, I'm going to indicate it's a factor. So before, when we were doing this in code, here's a way to do it on import. And there's pros and cons to each way. So I'm going to set sex to factor, and it's asking me to make a list of the factors separated by a comma. So I can go males, females, right? And hit OK. But now look at this on sex. All of my data just went to NA. So that's not right. I'm going to go back to factor, and this time, since I know on the Word document they are capital, I'm going to make sure I'm using capitals. Okay, now it found them all. So that's good. And then these others I'm going to set as well. So marital is a factor, and this one's really long, right? So this is where it's kind of helpful to just get my list that I've already made sure was exactly correct according to the data. And what I did is I looked in SPSS for how they were exactly doing it and made my list that way. So you would normally get that information from a code book or taking a quick look at the data file itself, either in Excel or something like that. But I copied that, and then I can just paste. And it changes it to a factor. For child, not so hard, just yes and no. Same thing for smoke. I can turn that to a factor, and it's yes, whoops, yes, no. But then what else? Education. That one's got a bunch of levels to the categorical variable. So I'm going to grab it from my cheat sheet and then paste it in. And you can do a little scroll to make sure you're not getting any weird NAs. It only shows us the first 50 entries, but it's mixed enough that if there was a weird NA, you'd probably see it. Source of stress needs to be a factor, and that one I'm going to copy. And this one gave me some trouble because if you look at your SPSS file, this one time, it has this extra information like too little time, comma, too much work, something like that. But the problem is this comma. We're already separating factors, the list that goes into this factor by commas, and there's a comma in the actual description there, which makes it not work. It makes it jack out there. So I made that adjustment on this DAT file so that it wouldn't do that. So I copied all of these and then pasting them into here. And that was just by doing it and figuring it out. When I saw later, when I'm looking at the summary of the data and I'm getting more NAs than I thought I would, then I know something's wrong. All right, we have a few more to set at the very end here. We got age group 3, age group 5, and education recoded. So this one is a factor. I'm going to go get my little age groups there and then paste and OK. I go back and check it. Okay, I have all these NAs. In fact, the only ones showing up are the 45 plus. So let me look back at my, so maybe it's got spaces between these. And I didn't include those. Like R is that picky. If there's a space there, there's got to be a space there. Let's try it again. I'm going to go age group 3 factor, and now paste the one that's got the extra spaces, hit OK, and hit refreshed, and now it's got them all. Age group 3 is a factor, and it's got all the age groups. And I'm seeing that age group 5 also has spaces, so no problem. I want this to be a factor. I'm going to grab these, but then I'm going to add the spaces in, since I missed that when I was making my cheat sheet. Hit OK, and go check it out. All right, everyone's there. Okay, in education recode, this seems to be the only one they wrote in lowercase. And copy, we'll turn this one into a factor. And check it out to make sure. Factor, all right, looks good. So that was a lot of work just to get the data in. Let's finish the import and take a look at it to see how well it's matching what we thought it would. We should have 439 observations of 21 variables. That's good. And then we can take a look just with summary Lab5. And now, so it's recognizing my categoricals as categorical, right? It's giving me just counts, and if it had too many, it just puts them into other. We have 1 missing for child. We have 17 missing for source of stress. We have 3 missing for smoke. And the variables we're going to be really focusing on for our chi-square are sex, smoke, and source. So we really want to make sure those are correct. Looks good so far, but that's the way you can double check. Like if you've already run the SPSS lab, you already have an idea as to how many are missing in each of those. And this looks like it came in well now. So if you look back at some of your prior coding, like in Lab 2, sometimes when we're describing categorical variables, we need another package. And we found that we could use Janitor pretty easily to get our count and percent of the whole for a categorical variable, which is exactly what we're going to need. So loading that up. Now we want some tables. Yep, that's right. I want my data set and the variable. So running that, I can see that I have 185 males, and they are 42.1% of the sample. So I want to do that same kind of thing for my other variables that I'm interested in, namely source and smoke. So there's all of my sources. So my count and my percent and the valid percent as well. If you report valid percent, you say something like of those who reported their source of stress, and that would be this percent column. But if you're also going to report the 17 who did not respond, you would use your regular percent column. Either way, you can do either. Just make sure you pay attention to which one you're doing and kind of be consistent. Okay, so we've gathered information, descriptive information about our categorical variables of interest, and we're ready to do some model testing. The assumptions, the basic assumptions for chi-square are pretty basic. You know, that you have categorical variables, that you have a random sample of a population, and that the data are independent. So not really anything to do on preliminary other than know that your variables are categorical and that you've set them up that way, which was why we were setting up the factors. So the first thing we need to do in R to get ready for our chi-square test is to create a contingency table. And the way we do this is by telling it, make me a table, and it's going to have these things in it. Lab5 variable sex and Lab5 variable smoke. Because my question is, is there an association between gender and smoking behavior? In other words, is someone's smoking status dependent on what gender they are? Like, does gender have a relationship with smoking status? And what the Chi-Square is doing is looking at, well, if we had no association, this is what the distribution should be. That's what we're expecting. But then you look at the data and see if what the data really are, the observed. And if there's a significant difference between the observed, the real data, and the expected, what we thought should be, if there was no association, when you have a significant Chi-Square, it says that those two are not distributed in a way to show no association. So significant means there's a difference between expected and observed. A non-significant Chi-Square means there's no real differences between what was expected and what we saw in the data. So first we make this contingency table. We tend to list the rows first and the columns second. You tend to want your columns being the less items, like smoke, yes and no. Now right now we have sex, male and female, but later when we go into our second task where we have many more, we're going to want that on the rows to have a neater table to try to work with, or at least one that's more manageable. So you tend to put your rows variable first, your columns second, and if you have a whole lot more levels to that categorical variable, you're going to want it in the rows. So when we create this table, it looks like this. We have how many males indicated yes they smoke or no they don't smoke, and how many females indicated yes they smoke or no they don't smoke. Now we're going to need this table as an object in the environment so that we can run the Chi-Square on it. No problem, we're just going to take this whole table and paste it here, but now give it a name, like let's say sex, smoke, assigned by that table. So we're creating a new item in the environment. Object sex not found. Lab5 smoke. Looks like it's struggling a little bit. Like sometimes there's artifacts like a space or a comma or something that can get away from you. So I'm just checking over. Sometimes I will like actually copy what it says here so that I can paste it just in case that's what it's tripping out on. It's picking it up there. I wonder if it thinks I'm doing some kind of, computation, like sex minus smoke, and that's not what I'm doing. So I'm going to go ahead and change that to an underscore, just in case that's what it's tripping out on. I'll do sex underscore smoke, which is definitely not a math function, and see if that runs. Okay, it liked that. And I didn't know what was going on there. I just knew it was throwing some errors and it was not putting the value in the environment like I wanted. And it was saying that it was tripping up on object sex not found. So it was just working it through to try to figure out how am I confusing R. So now that we have the value, the table in the environment, we're ready to run the Chi-Square on that object in the environment. So Chi-Square test, and then we're going to do it on that new table in there, sex smoke. Running that, and we can see the results in the console. So here's the results of our chi-square test right there. And it says it automatically used the Yates continuity correction. And that's good because that's what we would have needed with such a small table that's just a 2 by 2. Whenever you have a 2 by 2, like only 2 levels in this variable and only 2 levels in the other variable, then you want the Yates continuity correction estimate of the chi-square. So our chi-square amount is 0.337, 0.34. We have 1 degree of freedom, and our p-value is 0.562, which means we have a non-significant chi-square test. That means that the observed and the expected are not significantly different. And writing up that chi-square, we have this information. Chi-square, 1 is our degrees of freedom, n we need to get, so it's the sample size that went into this chi-square, and then the value of the chi-square and the p-value of the chi-square. So what's missing? We want to check out some assumptions. We need the sample size, and we're looking for effect size. So we're going to place our chi-square test in the environment. Let me go back to my test. I'll just copy that, and I'll call this task 1 and paste my test. So now I have the chi-square test actually in the environment. And the things that it has in this chi-square test item object, it's got the chi-square statistic, the parameter, looks like that's the degrees of freedom, the p-value method, but here it has observed and expected. So that I can use. When I'm checking assumption of frequency of 10 or greater, then I want to know what are the expected. So the way I can get that out of the table and over here to where I can see it is just ask for it. Task 1 and the variable expected. So I was expecting 35.9, 148.1, 49.1, and 202.9. None of those are less than 10. And I'm using 10 because it's a 2 by 2. Normally our assumption check for expected is 5. But because it's a small table, I'm looking for expected frequency of 10 or greater. And it looks like I'm fine there. So no assumption issues, assumption check issues in terms of expected cell size. We also need to get the sample size of how many were observed. We can do the same kind of thing. Task 1, and I want to know the observed. How did I know I had observed in there? It's when I looked over here and I saw I have observed and I have expected. So when I pull up observed, it gives me back that summary table, right? This is how many were observed, so not our missing values. So I can add all those up and find out that my sample size was 436. So we're good there, and that's what we would use back when we were writing our chi-square line. The 436 would be the n right there. Okay, I'm still missing effect size. And our effect size for a 2 by 2 table is called phi. In our package called psych, we can get to a phi command. And I can use it on just sex_smoke table. And it tells me the phi was negative 0.03. And that's the information I needed for the write-up. And let's take a look at the write-up on the SPSS lab sheet. So we had a chi-square test for independence. It was conducted to identify potential relationship between smoker status and gender. Results indicated no significant association. Then I have my stats line, and then an interpretive statement that it seems that smoking status was evenly distributed between male and female participants. And that's what our chi-square write-up would look like. Moving to our next chi-square test, it's still the same one, test for independence, but now we're bumping it up a bit. Is there an association between source of stress and smoking behavior? And sources of stress had a lot more than just 2 levels. So this is going to be a much larger table, but we can make our table and place it in the environment. I'll call this one source underscore smoke, assigned by table of Lab5 source and Lab5 smoke. My environment's getting full. Nope, it didn't work. Let's see. I misspelled source right there. So I looked at the error and all arguments have the same length. I'm like, okay, I'm not sure about that. In addition, unknown column sauce, whatever. So that's where I saw, okay, that must be my error there. So let's run it again. And now we have source smoke table. Cool. Now this gets interesting. So our chi-square test on source smoke, and when I run it, it says chi-square approximation may be incorrect in here. So we'll use a different chi-square function. It's just calling the summary of that table. And we're able to get the information, like we get the cases in the table, we get our chi-square estimate, degrees of freedom, and p-value, but we also get this warning that chi-square approximation may be incorrect. So let's check that out. We'll look at just source underscore smoke and see what's in there. Alrighty. So here, it seems like we don't have very many people in the yes cells, right? There's not even 5 in a lot of those. So that's probably what's making the chi-square be difficult to run here with the regular chi-square test. So we got the information, but we're also going to need to pay attention to that and indicate that our cells are not at 5 or greater. And we still need an effect size. Now to get an effect size here, since phi won't work on this either, and phi is only for a 2x2 table, we need Cramer's V. We're going to need a package called VCD. And then the function is called associative stats. So I'm going to run that on the source smoke item in the environment. So now we got some more information. We have the Pearson, there's our chi-square, we got our degrees of freedom, and we got the p-value. It doesn't give us the phi coefficient because that's only good for 2x2 tables. It does give us the Cramer's V, which is what we would need as an effect size for this chi-square because it's bigger than a 2x2. Now, problems with associative stats here is they never told us that there would be a problem with the assumption violations. They never gave us a clue. There wasn't any indicator that this might not be chi-square approximation might be incorrect. It didn't tell us any of that. and you can't actually run the Yates correction for it. So you can't get your coefficient, your chi-square coefficient estimate using Yates correction when you are using this package. So if you know you have a 2x2, you should use the chi-square test. If you know you're using more, you can use associate stats, but keep in mind that it's not going to let you know if there's an assumption violation. So, okay, we've run this test. This one is significant. So that's saying that there is a difference between what we observed and what we were expecting in terms of smokers associated, or smoking status associated with sources of stress. And that's all we can say about this one so far. We do need to gather information for a descriptives table, and what's helpful there is if you just go ahead and draw out what do you want on that descriptives table, and then gather that information, like start your descriptives table, however you want to do it, in an Excel sheet, and then ask for the information that you need for it. Like we have all the tables here. We can get sex smoke if you wanted to include gender on your table, right? And we have source smoke. So we have those. We also have the summary of the data set itself. Which can tell us about any of the others, like how many males and females total, or how many smokers were missing, anything like that that you feel that you want to keep on your table. And we can go back up to where we were getting the tables for our descriptives. So table source gives us both the percent, the number, and the percent for each of those. So let's take a look at the write-up for this one. A chi-square test for independence was conducted to look at the potential relationship between smoker status and source of stress. And that's where the table comes in handy, because source of stress has 9 levels, and that's a lot to put into a paragraph. Results indicated a significant association with our chi-square line, including our effect size, and our interpretive sentence. Distribution of smoker status was significantly different across sources of stress, and there were letting the reader know about the expected values less than 5, because that's a violation of assumptions. Alrighty, we have one more here, goodness of fit test, as our task 3. And this one's a different type of question. And instead of looking at equalish distribution, like a 50-50, or if you had 3 levels, it would be 33%, 33%, 33%. Instead of that kind of thing, you're looking at if you already know the distribution it should be, like in the population, does your sample match that distribution? For example, if we already knew that we're expecting there to be 20% smokers and 80% non-smokers, we can set that up as a goodness of fit test to look at, does our sample show the similar properties or probabilities that we would expect due to either population statistics or statistics from a different study that was done prior. So what we're going to do there is we'll do our chi-square test now we're just looking at smoke alone. We're not doing sex smoke or source smoke. We're just saying, out of the smoking variable, how are these distributed? And we're letting R know the probabilities we're expecting. We're expecting the first group, so those who said yes, they do smoke, to be about 20%. And the second level of that variable, the non-smokers, we're expecting that to come in at 80%. So running this chi-square test, and let's go ahead and code read here. We're conducting a chi-square test on the variable smoke, which is organized as a contingency table. That's that part right there. And we're using the expected probabilities of smokers 20%, non-smokers 80%, converted to decimal. So that's that, reading that line through. Now, our console indicates a non-significant results. In other words, with a p-value of 0.79, that's greater than 0.05. Our chi-square estimate is 0.069 or 0.07, and our degree of freedom 1. So this says that our sample is not significantly different to the population probabilities that we know from prior work. So that's pretty cool. Let's put this into the environment. I'll call it task 3, assigned by, and now I just want the chi-square test I already ran. And paste it right there. So now I have my task 3, and now I can look at those same things like observed and expected on that. And I still need sample size, but the same way that we did before, I can ask for task 3 observed and be able to see that it included 85 and 351, which added together is going to be my 436. We also want to do our assumption check, and for that we can similarly ask for the information out of our environment, and this one is expected. So we expected 87 and 348, and both of those are more than 5 expected in each cell. So we're good for that. And I'm not having you find a fixed size for goodness of fit test because it's just a little more convoluted to get to it, and we're not going to do that this term. But let's take a look at the write-up itself. So a chi-square goodness of fit test indicated no significant difference in the proportion of smokers identified in the sample, 19.5%, as compared with the value of 20% that was obtained in a previous nationwide study. And then there's my stats line for the chi-square and an interpretive statement that indicates this result, that it's non-significant, indicates that our sample is representative of smokers in the larger population. Now, how did I get the 19.5? That one was back in our descriptives. So when we did the table right there for smokers, we have that those who indicated that they smoked was 19.4 in R, right? If we round that, turn it into a percent and then round it to the tenths place, it would come out 19.4. So we got that, and the valid percent is 19.5. So maybe that's what I was using in the write-up there, not including those who didn't tell me their smoking status. But what if I need to know the percentages for each source of stress by smoker status, right? That's a different type of table that we haven't gotten into yet. So what I did to try to figure out that is first I did a search in Google. How do I do categorical variables contingency table with proportions or percentages in R? And from that, I saw this video, and you could see his coding right up because he talks for 5 minutes straight. But I can see here This part is him just making the data set to play around and show us how to do it. Then he made a contingency table with the information, where we already did that. We have our contingency table for source smoke and for 6 smoke, right? So we already did that part. But then he created one called proportional table, and he used this function called prop table, and he applied it to the contingency table already made. Okay, we can do that. And then he made a percentage table, which was just the proportion table that he already made times 100 to turn it into a percent. And then he combined them all with this, I think that's row bind, R bind, putting the rows together of the contingency table, the proportions, and the percentage. And then he asked for a summary. So I'm like, okay, I can do that. I don't have to watch 5 minutes of him. And so that's what I kind of built here, was those ones. We already have source smoke in our environment, and I called one source smoke properties or proportions. And then I made one called percent and did the times 100. And then I did that bind thing to put them all together. And I called that one table. And then now that I have all of those items over here in the environment, I said, okay, just show me what it looks like. And here is what the one looks like. But it seems like it's got way too many, like it's going over and over and over again. So that's not what I had in mind. So then I take, what I might want to do is just not have the percent one. So I'm trying to pick it apart. Why is this giving me 3? I guess here, that must be the count. Yep. And then this one is proportion. And then times 100, this one is the percent. Well, don't really need all of that. Like I probably can do with just the percent, and I don't need the proportion one, right? This one in the middle. Another thing, this is a lot of decimal places. I don't need that many decimal places. So this is a good place where I might lean into the ChatGPT or AI and say, okay, how about I put in my source code, and then ChatGPT says, looks like you're working with R. Here's what each line does, and this is useful for summarizing information. Okay, cool. But then I said, add coding to round the numbers to 2 decimal places. And ChatGPT responded with, to round, you can use the round function. Here's how to integrate it into your existing code. And that's what I needed. Like I already had my code, and it looks like all I needed was to put a comma 2 at the end of those 2 and put the word round, the function round, before it. So I can do that, round and 2. Smoke prop round source. It's not using the, it's after I've already made it. So it's adding on to it that. Let me just copy this code and put it right here. So here's where I made the properties table or the proportions table, and here's where I'm rounding it to 2. Cool. Here's where we're rounding the percent table to 2. And then binding them together. but I don't think I need this one. I think that's more than I'm wanting. So I'm going to back that one out and just get the source smoke and the percent. So first I'll round these two. And then redo that table, not worrying about the proportions since it's going to give me percent anyway. And then let's see what that one looks like. So this first group, work to time, tells me how many in each category, so my frequency, my count. And the second set is the percent. Cool. So it's back to, in R, you got to know what you're asking for. And then you are looking for, how do I get some help here? How do I Google what I'm asking for? And then maybe choose from some options to see, okay, how do I do this? Looking at code, seeing if it makes sense to me. And then if I want something more to it, and I already know what I'm doing, like I don't just put, hey, run a chi-square for me here, because I want to understand what I'm doing. But if I know what I'm asking and I'm saying, okay, help me do something more to this code I've already written, and then that's when I lean into the AI sometimes, just to, you know, hey, I already know what I'm doing, I just want to add this last piece to it, like either labels to a graph or rounding or something like that, or handling the RM, the NARM, remove the missing values. Sometimes I'll ask the AI, okay, how do I do this also accounting for the missing values? And that helps. Sometimes. You want to treat AI like a friend. And sometimes your friend is wrong, right? When you ask a friend for help on what they're doing in coding, and sometimes they don't have it right either. That's the same thing with AI. Sometimes the time it takes you to fix what they have wrong, you could have done it yourself anyway. So just keep that in mind. Anyway, that's what I was playing around with on this one. But we are good for everything we did here in our Lab 5 with ChiSquare. We ran 2 tests for independence, and we ran 1 goodness of fit test. And those are the way, this is non-parametric, and we use it when we're looking at data that is categorical, and even the outcomes are categorical. So it's a way of seeing if our distributions, our actual distribution observed, is similar to or different from our expected. So hope you enjoyed, and I look forward to seeing you at the next lab.